The next thing we need to do in our project is connect the RGB or red, green, blue LED to our Arduino. But before we do that, let's review or to go over some simple circuit concepts so that we can connect it correctly. So let's define what voltage is. Basically, that is the pushing potential that electrons want to move. It's kind of a measure of how crowded the electrons are, and the more crowded they are, the more they want to jump to something else or move along a wire, or the more they're willing to do some kind of work for us. We can kind of think about voltage in terms of like a tank full of water. It's the pressure. So it's analogous to the pressure of the water at the bottom of a tank. A voltage difference is meaning that it is that energy or that potential that is going to push electrons along a conductor. Everywhere on a conductor, the voltage will be the same. So if I have a copper plate or some other metal good conductor, the voltage everywhere along that is going to be about the same. And similarly with a wire or a conductor wire, voltage the same everywhere along that wire. If we have two conductors that come together and they have the same potential, no worries, everything stays the same. But it's kind of like similarly connecting two full tanks that have the same potential. If I connect those two at the bottom, I'm not going to have any flow going through the connection between those two tanks. However, if I were to connect a charged battery to an uncharged battery, then I have a difference in potential, and that causes electrons to flow, which is similar to what would happen if I had a tank that was full and I connected it to an empty tank. I would see that that water would flow and until the two had equal levels or equal potential. In electricity, that happens really quickly and sometimes kind of violently, so it's not a good idea to connect a charged battery with an uncharged battery. Electron flow is basically the movement of electrons. We call that current. Its symbol is I and its units are amps. It's a measure of how many electrons are moving past a point per second. We can think about that in like a fluid flow in a pipe. And unless we have sparks flying somewhere else, the current on a wire is the same everywhere along that wire. We can think about resistance. That's another thing that you will see in simple circuits is a resistor. Its resistance is the restriction or how much it's restricting the current for a given push power or electrical potential. We can think about it like kinking a hose or narrowing a pipe. It's resisting that flow of electrons. If we put all those things together, we can connect a circuit and we can do some calculations. So I have, just like I would in maybe a water circuit, I could have a water pump that is giving some push potential and it causes flow to go around a pipe. It might meet a narrowing of a pipe so that it would resist some resistance. And then after the narrowing pipe, it would reach a low pressure region. Similarly, we can connect an electrical circuit. Given a power supply, it would give some high potential or positive potential that would push electrons around the circuit. They may meet some resistance that would control the flow of those electrons, and then it would come back around to a low potential or low electric potential. We call that ground or 0 volts. That would be an animation of kind of given a certain current would flow through a circuit if I have a specific voltage and a specific resistance. We can use Ohm's law to calculate any of those different variables. So for a given voltage potential and a given resistance, I can calculate how much current is flowing through. Any one of those variables, given the other two, I can calculate. And that is called Ohm's law. You can think about it in rearranged forms, but I always remember V is equal to IR, and then I do the algebra to calculate whatever it is that I'm looking for. Kirchhoff's laws, there are two Kirchhoff's laws. The first one we'll talk about is the voltage law, and it says that in a circuit, all of the voltage increases, meaning any batteries or generators or otherwise electrical supplies, have to equal all of the voltage decreases or drops. Those are things that are going to take up energy, like resistors, lights, motors, as you go around a circuit. So voltage increases, all of the batteries have to equal all the voltage drops across all of the things that are going to be doing some work in a circuit. The current law says that anything going into a node, any current going into a node or wire junction has to equal the current going out of that node. So if I don't have any nodes or separations in a circuit, it just all goes around in a circle. That means the current that's flowing through the circuit is the same everywhere. If I do have a split, like right here would be a node, the Kirchhoff's current law tells me that the current coming into that node is equal to the current coming out. So I, being the amount of current coming into the node, is equal to I1 plus I2, which is the sum of the current going out on those two branches. And similarly, I1 and I2 will come back around and meet at this other node and equal the sum of those equal the current coming out of that node. So we can do an example using these laws and Ohm's law, Kirchhoff's laws and Ohm's law. So I've rearranged Ohm's law here because I'd like to calculate current. So if I have a battery that is 6 volts and a resistor that is 1200 ohms, I can calculate what the current that would be flowing through the circuit. 6 volts over 1200 ohms is equal to 0.005 amps or 5 milliamps. That's sort of the typical current that we're going to be dealing with, those levels. Because we're going to be dealing with a LED, a light emitting diode, let's look at what that would look like in a circuit. LEDs are sort of special because they can handle a specific amount of current, and given too much current, they'll actually blow up and not really explode, but they'll burn up and they will cease to work. So we always have to put a resistor in the circuit with an LED. LEDs, depending on their color, will have a typical voltage drop across the LED. This one is a red LED, which has about a 2-volt drop across it. So we need to calculate to see what kind of current we'll be sending through our circuit. Our supply on our Arduino is 5 volts, so that's why we've used 5 volts here. And you've been given resistors, one of which is a 470 ohm resistor. Current that a light emitting diode likes to run at is about 10 milliamps, so we can go through the calculations to make sure that we're not exceeding that. Above 20 milliamps, that diode will die and no longer work. So we'll use Kirchhoff's voltage law, saying that the supply, so the battery supply or our Arduino supply, 5 volts is equal to the voltage drop across the diode plus the voltage drop across the resistor. So to figure out what the voltage drop across the resistor is, I'll just rearrange that. The supply minus the voltage drop across the resistor gives me 3 volts, so I know I have a voltage drop across the resistor of 3 volts. I can then apply Ohm's law. The current through the circuit, which is going to be the same as the current across this resistor, is equal to the voltage drop across the resistor divided by the resistance. So I just plug those numbers in and I get 0.006 amps or 6 milliamps, which is below the 10 milliamps, which is sort of optimal for the diode, but it will still work. It just won't be quite as bright.